I'm going to review this Mr.Signal process calibrator. This is a handy little piece of gear. I've had a little bit of a play around with it already and I'm quite impressed by it. And this was supplied to me for free from Banggood. Thank you very much Banggood for sending this to me. If you want to look at this thing in more detail, check out the links down below to Banggood. Let's get started. Here's the box. Now the model number on this one, there's a few different models available and these are the specs. Let's just have a close look at these. So the one I've got is actually this one here. The MR9270S Plus. So it does quite a lot, inputs and outputs, so you can actually measure voltages and stuff like that as well, within reason. It's made for machinery, so it's not like high voltage stuff. If you're doing small bench work, then you probably don't need to worry about that. It could be very handy. Apologise for the mess in the back of the desk there. I'm working on a few projects right now and it's all kind of shoved to the back out of the way so I can do this review. No looking at the back to see what I'm working on. Shh, it's a secret. There we go, comes in a nice bag. It's got a belt strap, carry handle, it's got a little zip pocket in the front. What's in here? Anything? Anything in the zip pocket? No, nothing in the zip pocket. Back at the front, we've got in here a little certificate thing. These kinds of plastic cards are really handy if you get into things like screens on phones. You get warranty return stuff, obviously in Chinese because it's straight from China. And we have a user manual, actual paper user manual. Let's have a close look. Nice little picture on the front. Colour manual in English, which is nice, and it mentions again the same thing as on the back of the box with all the various functions it has. Yeah, I'll try and get a shot for that, maybe freeze frame it or something. I'll do that for each page. Next page. Of course you can probably download the manual online. I think it's probably on the website actually where they list this particular item for sale. So you can probably just get the manual and have a good look through it, but the specs don't look too bad. Resolution's alright. Position looks pretty good. 25 ppm for most of it, thereabouts, you know, looks reasonable. And you can see it's quite limited ranges, like current, right, these are the outputs section. So current's 24 milliamps output maximum and 12 volt maximum output. You can also output up to 10 kilohertz. Millivolt range as well, temperatures and output temperatures, so you can test thermocouple input systems. I'm not quite sure what this PT, it must be for thermocouples as well. And input section, again it's only quite limited because it's not meant for high voltage stuff. Current up to 24 milliamps, voltage up to 12 volts again. And it's basically the same sort of specs as the outputs. The inputs and outputs are very similar, although it doesn't list it there, does it? I don't see it. But there's resistance measurement over here. This can output resistance, not just input resistance. It can do both. So I seem to have missed that section in here. It can do resistance as well in here. So you can actually output resistance up to 400 ohms. A few pages there. It does quite a lot. It's actually quite comprehensive. From playing with it, I've seen there's a couple of little quirks in the firmware, but as long as you watch out for them, it should be fine. Mainly to do with the display and handling of the cursor. Maybe that'll be fixed in a future one. I'll try and demonstrate those if I find them. I've only played around with it for probably, I don't know, 10 minutes or so. See, lots of pages, pretty comprehensive manual. And I think the retail price on these was about 160 US. I think there's currently a special on as well, so you want to go and check this out sooner rather than later. Yeah, probably got my hand covering half the bloody page, haven't I? Just say, just freeze each page if you want to have a look at it. Does MODBUS as well apparently. I've got no idea about any of that stuff, so I can't demonstrate that. Okay, here we go. There's the manual. Alright, what else we got? So we have a rear pocket. That's where the cables go. I haven't looked at these yet myself, but you can see they're still wrapped up. So we have, nice silicone leads. These are very nice leads. Just standard banana, 4mm banana plugs with clip leads on the ends. And there's also a data cable, 3.5mm jack with clip leads on it, which is quite interesting. I think that's for the MODBUS, was it? Or something like that, I can't remember. I'm not overly familiar with all the functions this thing has. I've had to play with it and just check the basic functionality, and that's basically as far as I've gone with it. I like to try and demonstrate things as I find them too in the video, so yeah, that's what it is. And the next thing, middle pocket. And here it is. It's sort of deceptively small. And in the bottom here, we've got some more stuff. What's in here? So we've got a strap for the bag so you can carry it on your shoulder, a shoulder strap, and we have a USB power supply, an adapter, a closer look, And there's probably a USB cable in there. Let's have a look. Up to 240 volt, and output is 1 amp 5 volt naturally, so it feels awfully light. I would be concerned about using this, I think. I don't know, it might be fine, but I'm just suspicious. It might be fine, I don't know. My paranoia. I think it's just a cable. Yeah, there you go, just a USB cable. Well, that feels like quite a nice cable. It seems alright, it's quite robust. That's quite a nice one actually. So the interesting is you've got this adapter here, which I'm going to get a closer view of. You see it's got L, R and earth. Left, right and earth. I'm guessing that's based on being a stereo adapter. Which one's left and right and earth? Well, earth is usually the sleeve. So it's got a TRS connector. So tip, ring, sleeve. Alright, so earth is usually the sleeve. Whether left and right is that one or that one, I don't know. I could probe it I suppose, but I don't think it matters that much. Now, I think this has actually got like a 485. Yeah, RS485. What's on the bottom in that plugged hole there. That plug I've already taken out because I've charged it up once, and I actually left the plug sitting on my desk, so here's the plug, I'll put it back in. So it kind of keeps the dust out. Moving on. So here's the actual unit properly. It's in like a rubber boot as well. I haven't tried taking this off yet and looking any more detail on it. It has 4 connectors on the top. As you can see it's got common, out, in, negative, and in, positive. That is a negative basically, and that's positive output. Although the negative on here does actually work with these as well, so if you loop it back into itself, which I'll show you, you can actually loop it back into itself and test the same measurements. You can do that. Now, interesting about these plugs, obviously because of the form factor and the size of this, these are not the standard spacing. Right, so you can't get one of these dual plugs and just plug it straight in. It doesn't work like that. Unfortunately, I did try. So here's like a standard plug pin out here, the standard spacing, and you can see if you try and plug it in there, it's out a little bit. But it's also a compromise I had to make in order to fit into this form factor, so I can understand why. This means you can't use those pre-made dual plugs like this thing. So you can see this marking on the front here, just reinforcing what's marked on the top about the connections. There's an indicator here which tells you when the output is turned on. Basically this is the user interface right here, and it's fairly self-explanatory. So you've got in settings and out settings, in ranges basically, and out ranges, and then also you've got cursors. And also you can see you've got numbers here, 1 through to 9, well 1 through to 0, and OK button there, although it's really small font you can't really see it too well, plus and minus. And you've also got things like the actual functions. So you've got ohms, hertz, millivolts, volts, milliamps, transmit, which is obviously the MODBUS stuff, 24 volt outputs because a fixed output 24 volts, and TC for thermocouples, and RTD. RTD actually I need to look that up in the manual, I don't remember what it was, I don't know, I have to look it up. And I'll see on the bottom, which I kind of showed you before but briefly. So here's the USB plug which I'll put the bung back into. There's a charging indicator, so when you've got the USB plugged in, it's charging, that comes on. Here's the power switch on the bottom tucked out of the way, so you can't accidentally turn it on by having something pressing against it, because it's within the boot, so it's all fine, you know. And over here is a 3.5mm jack for that adapter which I showed you before. Right, so it just sits in there like so and plugs it up, keeps the dust out of it, which is nice. And it says GBA, I guess ground, channel A, channel B, is that it? It's like a diagram of what the connector looks like. That'd be my guess anyway. Shall we turn it on? I think we should. Don't forget to check out the links down below for this as well. Just turn it on, hold it down a little bit and it comes on. And there's a display. Now there's quite a bit going on there. You've got some graphing going on, so you can actually see what's happening. This is currently set for 24 volt loop. That's the output section. This is the input section. So if I go to the output here, push that, and let's do 1 milliamp, and you can move the cursor around and change these settings. And it's pretty simple interface. Now obviously it's not doing anything yet. You can see the indicator's not on, so it's running. And also over here you can see it says off. You can see T on. There we go, it's now on. It's outputting 10 milliamps. But because there's no circuitry involved, it's saying there's nothing going on. Right, there's nothing connected to it, so therefore I can't restrict it to 10 milliamps or output 10 milliamps current. I'll turn it back off for now. And if I do say voltage instead, there's a voltage display. Now there is a quirk. If the cursor's over here and you change to a different output, I don't know which one it was now. Is it this one? No, one of them I did a change between something and it lost the cursor. Okay, I found it. Now if I do say like 10 volts on here, I change the ranges, you'll see it doesn't actually change. And then that's in volts here, it says volts, 10 volts. If I do that, it says 1000. If I push that again, it says 1000 volts. Little quirks in the firmware there. I did actually have one time where the cursor disappeared. That was quite interesting. So 12 volts max. If I change that, it says 1000. But it's, well, not 1000.0, but it's actually 10 volts output. So I don't know why it says 1000.0, because that doesn't really make sense. There's probably some reason for it. I don't actually know what it's doing. That part of the interface is a little bit confusing, but I suppose once you actually know what you're doing, it's probably a bit easier. Here it says volts, here it says range. If I swap them over, that says voltage up there, and then when I change it, it changes. It needs to link in to update the display in the firmware when you push this button here, because it doesn't update it until you change the value. So it's like it's a little quirk there in their firmware. Graphing is over here. So that's that. I'll actually hook this up to something soon and do some calibration checks and just see how accurate it is. I'll show you that stuff. But let's go through the functions first. Transmit. This is something I've got no idea what this is. I don't know. Hertz, so you can set frequencies. So that's 99.999 hertz in that range. Go to the next one. That's 999 hertz. Next one is also hertz, but that's showing kilohertz basically. Alright, that's the one where I had the cursor disappear. See, it's actually on the very left digit over here. It's gone. Here we go. That's what I was trying to find. So it's there, but it's over here. It's not actually on display because it's off the edge. A little bit of a firmware quirk there. And if I change the values again, see, it's coming back over there, and there we go, the cursor's still there on that leftmost digit. So it looks like it doesn't actually shift the cursor over. So it's a little bit of a firmware quirk. I mean, it seems to work okay, but it's just saying these things like, well, where's the cursor gone? It's because it's off the side. Anyway, millivolt output as well, so we've got the same sort of stuff on here. It's 110 millivolts, so it's obviously a high resolution one, rather than just voltage output. Thermocouple sensing. Well, let's just work through it. Ohms as well. Oh, let's just work through them, shall we? Jumping over the place. Millivolts are 1 hertz. It's 24 volts here. This is a 24 volt output, and you can set the current. Or it tells you the current that's being drawn. I think it is here. It tells you how much current is being drawn. I'll demonstrate this when I hook up my DC load. What else have we got here? So per. I don't know what it does. Let's look into that. Ohms, this is where you can actually set the output resistance up to 400 ohms or 399. When I push that, it jumped to C's and back to ohms again. I suppose you want to quickly check. I suppose that's part of the functions of that particular thing there. Maybe the resistance is based on reading thermocouples. Maybe, I don't know. Anyway, so yeah, 399 ohms there, and it's jumping to C. You can see you can output a temperature. Oh, I don't know. Functions that I've got no idea about. So, what else we got? RTD. I don't know what RTD is. It's very similar, actually. I don't know. And thermocouple, which I've kind of touched on, is you can output thermocouple values. You know, you put our temperature. I will tell you what the millivolt output will be, and that's the temperature the actual unit should display when you output these levels. And you can actually go negative as well as positive, depending. It's across the whole range of thermocouple. And you can also choose which type of thermocouple in here. The K-type is the most common, so it also displays up here in the corner. I will hook up to some test gear and show you what it's actually doing, so you understand it a bit better. So watch out for that, don't go away. Functions, it's got a whole bunch of stuff in here too, which I've only basically just played with a little bit. In program, so you actually tell it to do certain things like sweep across a range. In preset, so I'll do steps instead. In convert, so it does a conversion on the fly about what the inputs are. It'll measure an input and then it will output the same thing. So this will act like an intermediate thing, so you can put it in series with the circuit, see what's coming in, see what's going out. So that's what that's doing. So you can actually also adjust the output in relation to the input. You know, say it's like skews it or something like that. Recalibrates the output compared to the input ratio. And it works in a ratio, so that's pretty cool. Okay, don't do that. Graphing. Output graph zoom, auto zooming. Yeah, I don't know what this does. Auto zoom, yeah, I don't know. It might depend on what mode you're Port settings is probably for that connector on the bottom there. Let's have a look in there. I haven't looked in there yet. Baud rates and that sort of stuff for MODBUS and what have you. Does it allow me to change that? I think it probably will do. I'm going to do that anyway. We'll get out. Don't want to mess anything up until I know how to use it. Tools, recorder, PID panel. Let's have a look in here. I haven't looked at this yet. Okay. Alright, so it's monitoring. Okay, so you can use this to figure out thermocouple tuning. How do I stop this? Exit. Exit. Yes. Exit. Here we go. Use 24 volts. Let's have a look at this. I'm not quite sure. Maybe it allows a higher output. Did it? And okay, we'll find out, I suppose. Language settings, system settings. Just going to look in there. So you can change the screen display. So you've got themes. So you can change templates. I'm guessing. Input and output, which is what it's currently doing, splits view. So output option, input only, input graph, and some other stuff. How do I get into here? Let's go down to here. Screen, edit. There we go. In out graph. So in graph. It's a shame it's changing the background. I can't quite see what it's actually doing. But I think I'll leave it on in and out because I think that's a lot more universal setting. I think I'll be happy with that. Saving values, save state, so it means it will probably keep the states of the last used settings. Depends if you want to keep going back to what you just already done or not. Beep, fast ADC, interesting. USB and on, don't know what it does yet. Calibration, themes. Okay, let's look at changing themes. There's two themes. Theme 2, Theme 1. I don't know. I may or may not worry about it. I mean, what I've got now I think seems okay. Function button is presets. This is the function button's how I got into this menu in the first place, so I'll be careful about what I do here in case it messes something up. Program run, convert, logger, Mr. Mod, heart. Oh, it does have heart. Okay. I'll leave it a preset, I think. Get out of here. And get out of here again. So that's that menu system. So let's look at this and test it. Actually, let's see if this does now. Let's see if it's now I've changed that to 24 volt input. See, it's flashing 24 volts. Let's see if we can actually output 24 volts, shall we? No, it does 12. Okay. So what this 24 volt thing is doing? Might have to read the manual. Don't do that, do we? Okay, I just found a little thing. I thought better read the manual and just see what I can find about the stuff. So apparently there's an input setting here. So we can actually change some functions. So if we hold the output button for a couple of seconds, it gives us another menu. So we can change loop voltage from 12 volts to 24 volts, for example. And also the output voltage, output milliamp ranges. So you can choose which one you want for your testing. In the setup there's an option there for different display types. Apparently if you hold this exit button down, it will change between each one. So that's the output screen, I'm guessing. That's input screen. Graphing. Another graphing. Back to original. So I've got a shortcut to that menu. Instead of having to set a menu when you change those displays, you can just use that button there. That's pretty nice. The other thing you can do, if you want to, like, instead of having to put a specific value in here like this, using these buttons, if you want to do something, particular value you want, say if you want that, instead of going through these up and down like this, you can actually do it a different way. You can push that button there and just type it in. Alright, so 1, 2, 3. Okay, there you go, 1, 2, 3. So it's a nice quick shortcut way of doing it as well. That's nice. And then when you're in the voltage mode, apparently, if you hold the output down, you get another menu, which again sets the output voltages you want to have in the ranges. I'm not quite sure where you want to restrict it, maybe it changes something else. And you can also do things like protection, which I think I'll turn on actually. Protection, edit, turn it on. Right. We turn So it's now turned on protection. So if it's a short circuit on the output for 2 seconds, apparently, it will shut off the output. So apparently the XMIT transmit, I knew it meant transmit, it's supposed to simulate a transmitter somehow. I'm not quite sure what the situation is of that. Maybe it's a MODBUS thing, I don't know what it is, but that's what it is in the menu anyway. So in the thermocouple menu, apparently, we can get into the sub-menu, which allows us to change things like the temperature. So let's go to thermocouples. Is it on the output menu? Good guess. Right. Cold junction temperature, tells you what it is. And you can change between centigrade, Fahrenheit, stuff like that. Cold set inside outside. So I suppose you can get an external probe and measure it and set it up that way. I don't know. 110 millivolts or TC, I'm not sure what that bit means. And obviously there's a default thermocouple, so you can select which one you want to use. So go into the menu system. Another way, but I don't know, I guess you can choose it either way, can't you? Cool. It's got lots of hidden functions, it's pretty cool. Okay, so I think that use 24 volt thing is this section here. It's like an independent, so it actually isolate the input and output from each other. So I think this is what it's actually doing here. So it's got isolation in here, and this is the settings here mentions, and to keeping it after reboot as well. So I think that's what it's about. I think so anyway. It's not particularly clear. So in the frequency mode, if you hold the output down here, these are the options you get, also the frequency ranges and the types. So pulses, PWM, speed, or Q-poles. I don't know what that is. Peak voltage. Seems that each function has got a little sub-menu hidden away to a bit more configuration. So in here it also mentions about the fast ADC function. So it will improve the speed of measurements, and also USB and on, which I also mentioned, is about plugging the USB power in, and that will then power the unit up automatically. So here you can see I've got my Siglent unit set up here. So I've got my 6.5 digit multimeter sitting here and my DC electronic load. I'll be using both of these to demonstrate functionality. The lighting on here is a bit dark because I've got my light here turned off, otherwise it ends up glaring out a little bit, so I thought I'll just leave it off. So here's the unit here, plugged in, as you can see. I'm just going to step through some of the outputs. Now you can see I've got some stray voltage showing up on here. It's RF and stuff like that getting into these cables. You can see I'm picking up noise through the cables themselves. Alright, so I'm actually tempted to do a relative measurement based on that. It's a bit hard to actually sort of get precision out of this when I've got so much noise in the area, so let's do that. That'll give us a closer measurement. Okay, so let's turn the output. I've got it set to 10 millivolts right now. So let's turn the output on. What do we get? About 7.8. Again, it's hard because of the noise and the other stuff going. So if I turn the relative back off again, we're seeing 12 on there. We were by about 2, so if I turn the output back off, getting sort of 4.5 or so there. If we move the cables around a bit, it changes. You go 2.8 there, I'll turn the output back on, 12. It could be this is slightly out. I can't measure this precisely with the amount of noise I've got in this room right now. All the lighting and stuff like that doesn't help. If I step down by 1 millivolt to go down to 9, it does step down by 1. So I was going to keep stepping down by 1 millivolt until I run out of millivolts to step down by. It may even go negative, so if I go down to 1 millivolt, it'd be sort of get down the noise of what I've got in the room here, and they won't go negative. I think there is a negative option, I'm not sure. Do 100 millivolts, down 102. Again, I was getting a couple of millivolts of noise as well, so I was adding on to it. So when I'm getting these levels this low, it's the noise is affecting these readings. Okay, so 300 millivolts. It's looking fairly accurate, really. It's looking pretty good. If I go up to 1 volt exactly, here we go. If I turn the output off, what I do is actually go to manual ranging. Let's do 20 volt manual ranging. I've got 10 meg input, let's do 10 gig input instead, shall we? Turn the output on. 1.005, turn it back off again. 003. So again we've got that bit of noise in there, and there may be an offset of a couple of millivolts there. Turn the auto zeroing off, for example, it will speed things up slightly. If I go back to 10 meg, it might help reduce some of the noise. Back to 1 volt, 1005. So I'll do relative against that one. Turn the output back on. 1.003. So it looks like it might be out by a few millivolts, potentially. So let's go up by volts at a time. Turn the output back on. 2 volts. Turn the relative back off again. And auto zero back on again. Auto zero slows down the measurements it takes. As you can see, it slows it down. but it means it resamples every second. Every sample, it keeps resampling itself and making sure that it's referenced against zero, well, true zero. It helps that measurement accuracy a little bit. So a couple of millivolts out there, so 2, 3, 4. I'll just keep going up. I'll have to say it every time, do I? Okay, let's go up to 10 volts. Yep. 12 volts. Turn the output off there. Again, you can see what that difference is. So it's fairly close. Right, there's not much. There's only, you know, you're talking about a couple of millivolts accuracy error there. Whether it's just because of the noise in the area and that sort of stuff, who knows. Now I can also output resistance as well. So if I change this output, I'll turn the output off, and I'll go to resistance range, just 2Y obviously. And if I go to the resistance range on the meter, and let's output a resistance. Okay, there, turn the output on. That's saying 0 ohms. So that's what I'm measuring on the leads. Let's just short the leads together at the meter end. So over here I'm going to shorten together, plug it in there to give us a short, and we'll see what we get in the meter here. So that should be our relative measurement. Okay, so I'll do that. Plug that back in. So a short on this, which is displayed as 0 ohms, as you can see here, is showing 1.1 ohms. So I'll increase it to 100 ohms, 200, 300, and 390. So it's not bad. I mean, it gives you a pretty reasonable representation of resistance. Obviously it's putting like a MOSFET or something in there, which is then used to change the resistance. So I'm changing by 1 ohm at a time here as well. Alright, so if I change the range back down, so it's 7 ohms I've got it set to right now, 4 ohms. So, you know, any resistance I want in that range between 0 and 399 ohms I can set. Kind of goes to 15, so it's fairly close. That's not bad, is it? That works right. So I've now changed over to be on the electronic load here, and I've got it set now to milliamps, so output, so current, or current limit. Okay, so I've got it set to 1 milliamp right now. So I've got into there by going out, then milliamp range, like that, and it's obviously zeroed it again, and let's go up to 1 milliamp, right? And that's what we get in display. You can see it's outputting 12.3 volts. Now on here we can also do that thing with the extra submenu, drop in there, and we shall put this onto, hopefully, that one there, to edit. That's on 24 volts now, let's exit that. So that should now be putting out 24 volts, and it is putting out 24 volts. So it's obviously meant for doing, you know, process calibration stuff. And let's do the current on that, 2 amps. Right, so this is going to limit to this current here. Okay, what I've got set to there. We have to have some kind of output in order for this to generate an output. You can see here. Alright, so 1 milliamp is when it starts kind of kicking in. Or if I go to a much lower level, what's that, 1 microamp is it? It starts to put out something. Where do we get it? So we'll actually scroll through as well like that, which is quite nice. Just want to find out what the limit is where it's actually going to have enough power to drive it properly. This is probably more to do with the electronic load, the burden voltages on it. So it's basically 23 at least. Getting there, pretty much there, isn't it? So if we say 300 microamps is like what I need in order to drive this load, basically, right, minimum in order to get a voltage reading. So okay, that's interesting. So that's now set at 24 milliamps. I've changed this back to 12 volts again, so you can see on here I've got 12 volt output on here. Okay, and also I'll turn the output off on here, it will disappear off the load. Okay, so that's working fine. So this will restrict to 24 milliamps, but obviously that's the maximum, so I want to bring it down a bit, say 19. If I turn this load on, we'll see what we get. So it's loading it down with 10 milliamps. So this isn't going to be outputting the full current right now. So if I increase the loading on this, let's say 20 milliamps, I'll try and draw the full amount. Actually it's 230, because we're trying to demonstrate this unit controlling the current. You can see the voltage dropped right off. This has dropped the current off at 19. We're reading 20 here. Okay, so let's do 15 milliamps on here. I'm getting 16. 10 milliamps. We're getting 11 or so. 5 milliamps. You know, it's there. There's a slight error there. Which one's wrong? I don't know. I could probably figure that out by plugging the multimeter in series and measuring a bit more accurately. If I do 24 milliamps, which is a max, it's doing 25 there. So you can see it's topping it out, and that's actually controlling the current which this thing can provide. So that's the output functions. Okay, so I've now got my Siglent multimeter here set on frequency. I thought I'd better go back to it. I missed some of the functions. So I've got the output on this turned off currently. You can see it's picking up radiated noises and 50 Hz hum was coming up there. So you know, it just confirms I've got noise in the area. So if I turn the output of this unit on with no frequency and I put it, say, 1 Hz, am I going to get something? Yes, I am. Showing 2 Hz. Just 2 Hz. There we go. There we're getting 2 Hz. It's also the noise is affecting things. So now you're getting more accurate output there. So yeah, I'll show you what I'm doing here. Put it over here. Okay. 13 Hz. 25 Hz. There you go. 83 Hz. So you can just, you know, you can see, you can just dial up any frequency you want and you'll basically get there. Let's do a range change. It's doing 1 kHz now. And also we can change it down a bit. Do another range change. It's doing 9.99 kHz. We can see there's a slight error there in frequency. Yeah, not much of an error there. That's okay. So that's working fine. So the other thing we can look at here, turn the output back off. I need to try and cover everything, can I? You've got 24 volt output on here as well. Go back to there. If I turn it on, it'll just output 24 volts. 24 volts coming out. Nothing else going on there. Next I'm going to use the thermocouple output. So I need to find the temperature range, which is on here, which is the button there. Now I'm expecting a thermocouple. Output is currently turned off, as you can see. And we'll turn the output on. And we shall adjust the range. Okay, so it's starting from 1000 degrees C, you don't want that. Let's do 10 degrees C. There we go, we're getting about that, 10.6. Again, there's going to be noise which is affecting these readings because it's very low voltages. Right, and as the voltage comes up, the noise will be less influence on it. So there's 30. Let's go up to stepson's cat's arrived. Can you tell? So where was I? Now let's keep going. So 100 degrees C, that's what we're getting there. And you can see as the millivolt rating comes up, it should get better. Let's do 200 degrees, 300. Let's just go up to, you know, 720. Sounds good, doesn't it? Right, so this can do, I think it's 1300 or something on a, yeah, go 1370 on a K-type. I think the meter's got a restriction of 1300. So 50 millivolts. And you see how much more stable it is when you've got high voltage coming in without the noise being in there affecting it. So yeah, you can simulate a thermocouple. So the next test is the input side of things. So let's have a look at that. So we have to plug this into the input. And over here I have the Ian Johnston PDVS2 Mini. I suggest you go and have a look at these things. Look at ianjohnston.com. There you go. Go to that website there and go and check them out. This is a prototype which Ian sent me to do review videos on and stuff like that. So this works really well. I'm quite happy with it. It's very accurate. Ian does some really nice work. So go and check those out if you're interested. Right, I'm going to use this because there's a nice convenient bench supply to use here, and it's only low voltage requirement. This does up to 10 volts, so it's certainly capable of doing what I need to do, which is to measure up to 10 volts on this thing. Let's get set up. Now obviously I'm just going to turn this thing on now, so it's not going to be stabilised, but it's going to be close enough what we're doing here. So turn it on. These cables are going to be in the way, aren't they? That's going to be annoying. This is the output voltage. Now we need to set this to be accepting an input voltage. So this is the input side here. So input over there. Sorry, push the right button. We want to measure voltage. And we've got all these cables in front of my screen, so I can't see a thing. That's annoying. This is the bit we're looking at here. Although I could change the screen function. Output, input. There we go. And you can see it's got graphing in here as well. So you can actually see the graph of both positive and negative voltages in this case. So that's quite a nice feature. So let's generate some voltages with the PDVS2 Mini. 1 volt. That's fairly accurate. 1 millivolt out. Still another volt. There you go, 2 volts. still 1 millivolt out. And you see the graphing, it shows what's going on. So if I wanted to reduce that. Now that fast ADC feature, that might be beneficial in this. I'm not sure why they wouldn't have that turned on. Maybe it's a power saving thing, I don't know, but maybe it's something worth turning on, see if it actually makes this much more responsive. So this goes up to 10 volts, and there we go. So it's got a 1 millivolt error across the whole range, which is actually pretty damn good, I have to say. That's not bad. So what I might do is go into the settings on this and do that fast ADC function. System. We'll turn that fast ADC on. Enter. See what that does for it. Turn it on. Exit that. Exit that. And we'll see if this improves the graphing at all. So still obviously doing 10 volts right now. That is more responsive, isn't it? Yeah, that is more responsive. So the fast ADC is definitely definitely an improvement. Actually, that is noticeable. So that's good. Why they wouldn't have that turned on by default, I'm not sure. Maybe it's a power saving thing. That's just my guess anyway. I'm going to leave that setting turned on. Go down to changing by hundreds of millivolts, and we should see hopefully a linear step between each one. So each one I think is going to be 1 millivolt out. It's obviously a slight calibration error there by 1 millivolt, but they all did the same thing. So that is fine. That looks pretty accurate. Let's go down by 10 millivolts. See if it does the same thing. So the actual accuracy of this thing is pretty linear. Yep. Let's go down by 1 millivolt. Yep. So using this meter I can actually maybe try and see how much it's actually out by. So 100 microvolts, 200 microvolts, 300, 400, 500, 600, 700 microvolts. That's when it tripped over, so it's out by about 700 microvolts. That's not bad really, is it? Maybe it's temperature related as well, maybe being a bit warmer might change things. It's currently 26 degrees in here, according to my benchtop meter here. Gives you an idea, I suppose. That works alright. That's actually pretty accurate, I'm quite surprised. What other inputs does this thing have? So we've got milliamps, as I said before, hertz, millivolts, ohms, RTD and TC again, if you want to use it as thermocouple capture. So you can measure resistance up to 400 ohms again as well. Let's do millivolts and see how much accuracy we get out of this on the millivolts range. So I'm currently way over scale, so let's just bring this down. Just like 312 is like the maximum. I was really bashing it then. Alright, so do 100 millivolts and see how we get. So there we go. So that's about 30 microvolts out in comparison. If I do it closer towards full scale, which should be 300. There we go. There's 500 microvolts out there. And obviously the noise in these cables is affecting it too. So I'm going to see if these stay linear. So there's a slight step there. It stepped up slightly by a little bit. Yeah. But it's not bad. Yeah, it's not a dead linear response on that. It's each one stepping slightly, but that's okay. Do there, and let's do by 1 millivolt. There we go, 0.99. So it's pretty good. You know, it's slightly out. It's not, you know, perfect, but it's pretty good. Let's do by 100 microvolts. Here we go. It's almost right. Look, just a little bit of rounding error there. 200, 300. Yes, there's a slight difference, but that's not bad. Not bad. Pretty impressive actually. And here's a display showing the graphing in a full screen. Full screen graphing. I've unplugged it all now, so you can't see it too well, but I can do resistance input. Maybe I'll do it. Show resistances. So that's quite nice, that graphing feature. Anyway, that's what I was trying to get back to, is this one, because I want to show you something. So what I'm doing now is I'm plugging the input back into the output. Technically you don't have to hook this one up unless you've got that 24 volt isolation enabled. So it's running through the cables back into itself. So whatever you output, you should see on the input over here. So I've got it set to volts right now, volts range. And this is, yeah, let's do 100 millivolts. Turn the output on and step up 100 millivolts. And here we go. It is indeed seeing a slight error. So its reference for the voltage is very slightly off, as we basically already determined by using this thing. Okay, that's alright, but what you're getting is pretty much right. Let's go to tens of volts. There you go, doing 11 volts there, and 12 volts maximum. You can also do 24 volt output, don't forget, so let's come over here. Let's go to 24 volt, and let's actually turn it back on, and there's the output voltage here. If I look at that output there, it's not showing us, that's the current available, 25 milliamps. And you do the same thing for other features as well. So if you want to do resistance, and do the input and resistance as well. So now I'll turn the output on, the input and the output should say the resistances. So it's like a little self-check you can actually do on the unit and make sure it's actually reading as it's supposed to, because they work independently of each other. That's pretty good. And you can do that for each of these functions. Obviously the input ranges, you haven't got as many options there. You can still do those features. So that's pretty cool. Now I've been playing around with this now for about an hour or so, and the battery's only down to 90%. There you go, 90% battery. So even though I've been playing around for about an hour, the battery still lasted quite well. Obviously it depends on what you're doing. When I'm driving the electronic load, so it's actually got a bit of current coming out of it, it's trying to provide 20 milliamps or something, then it's obviously going to be draining that out of the battery in order to generate that. So my opinion of this is actually pretty good. If you're looking for some kind of calibrator unit which is very versatile, configurable, you can set up the ramping and the steps and that sort of stuff, and it's got MODBUS in it, which I haven't gone into at all because I've got no idea about MODBUS. It's not something I do, so I can't really give much enlightenment about that part of it. So I'm hoping that what I've showed you is enough to make you understand what this thing's capable of. It's a good unit. It's surprisingly accurate. It's got a calibration menu, so if you need to tweak the calibration, maybe it's possible to. Maybe, I don't want to go in there and mess with it in case I do screw something up, but if it was out of calibration enough to make you worry about it, then you can actually go in and calibrate it, the looks of it. So it's nice, it's got those features as well. I mean, obviously I've got the RS485 interface on the bottom there, which I haven't even touched on either. I thought maybe that's part of the MODBUS, I don't know. It's not what I do. It's good, so make sure you check out the links down below. Maybe consider buying one, because the price is pretty good considering what it can do. I'm actually quite impressive. I think the thing I'm disappointed with about really is the little quirks in the user interface here with the cursor positioning and the display not updating when you change this range. That's only really minor, just a little thing which irks me slightly. It's just not perfect. Let's put it that way, it's not perfect. But otherwise it all seems to work fine, and obviously these being non-standard spacings, that's a bit annoying as well. But again, because of the form factor, I'm not sure they could have done much about that. I mean, maybe they could have done, because they are as pairs, so maybe they could have shifted this socket over there and this socket over there more. Let's look under the boot. I mean, there's the boot there, so maybe there was space. They could have maybe moved it over a little bit. That's what's on the back of it too, in case you're interested. 3.6 volt, 900 milliamp times 2. What's actually in there? Has it got lithiums in there? Let's turn this off. Let's have a look inside. Well, at least in the battery cover. I'm not going to open it right up, although I could. There you go, that's what's inside it. It's got 2 lithium cells. ICR 14500, 900 milliamp hour, 3.7 volt lithiums. So that's pretty nice, which means if you need to have like field use and you worry about batteries going flat and you can't recharge it, you can always carry some batteries with you and pop them in. Also, when these get aged, it might take a few years, but when these age and start to have problems with capacity, you can replace them, which is nice. Instead of being a fixed like lithium pack, it's one of these, which is nice. Now what I was talking about before was these spacings. Let's go back to that. So what I was looking at is whether it's actually possible to put the right spacing in there. Well, if you look at it, it's close to the side, but that might have been possible. I mean, maybe they could have got the socket in there and moved that one over, 5 mil or whatever it is, 8 mil maybe. It would have been close to the edge, but I think it still would have been doable. So that's a shame they missed the opportunity there to actually squeeze that in so you can use a standardised spacing. Then I could have used this for doing more precise measurements. Alright, so I've taken the screws out. Let's have a look inside. What do we find? So there's a flex that goes to the display, so let's fold it over the correct way. Not much to see there. back to the boards. So we've got a display module there, obviously it's all nice. It's got an inductor down there, I'm guessing that's probably some kind of boost converter. And can I fold this other board out? Not sure I can. Yes, I'm pretty sure it's got header pins in here. I don't want to like pull it out, it's the thing. I don't want to risk breaking it or messing up its calibrations. So I'm not going to pull it right apart. But there's a whole stack of stuff inside there. Battery terminals look like they're wired. Wires for battery terminals. Just see down inside there some wires. Yeah, I'm not going to go too much further with this, I don't think. Yeah, I'm not going to risk it. I don't want to break it. It looks like it's nicely designed. Actually looks pretty impressive. I'm a fan. So when you don't have the bumper case on it, it won't actually stand up. Well, it will barely, but it's not great. So I recommend keeping the bumper on there because it's got the feet kind of in there. You can see it's got protrusions, which are the LED sticking out a little bit there, and a button. Is it the bumper? No, it's a bump. That's a USB bumper there. So if these were sticking out very slightly more, it'd be alright. You could still use it without the bumper on it, but the LED's basically making it rock. I don't know if you can push that back in a bit. I don't know. I'll just put the bumper case back on. Okay, pop that back in. And we're back to how we were. Let's make sure it still works. Push and hold it. There we go. You just tap it off. You push it to turn it off, and you hold it to turn it on. Thumbs up. Good unit. I recommend if you're interested in calibration stuff or process calibration or process monitoring maybe, I don't know, but get one. It's good. Use my link. Make sure you use my link. That way I'll get a commission. Helps my channel. I can buy more stuff then. Make sure you subscribe, click that bell icon, all that sort of stuff. Comment down below. Give me your feedback, any observations you have about this, that kind of thing. And I just like to have a chat generally. I read every comment, so make sure you do come down there. Also, thank you to my Patreon supporters, who I really much appreciate. I don't thank you enough, I don't think. You know, it helps me to buy things for the channel, helps to keep me motivated. That's why it's important, especially the way things are with YouTube these days. Motivation's pretty hard to keep up. So, thanks for watching, and thanks for watching to the very end, because that really helps my channel too. Long watch times help my channel. So watch to the end always, if you can. If you leave it running, it's fine. Okay, we're done. Catch you later. See you next time. Have a good Christmas. Bye.